So today, ladies and gents, we're going to be talking about quadratic functions. So in general, the function y equals ax squared plus bx plus c, where a, b, and c are constants and a cannot equal 0, is called a quadratic function. Why is it important that a does not equal 0? Well, if a equals 0, then we will have no x squared, and we'd be left with y equals bx plus c, which is really just another form of a linear function. And so we really need that x squared. That is the part that helps make it a quadratic function. Now the graph of a quadratic function is called a quadratic graph. What we're going to do first is start with the simplest of quadratic graphs, y equals x squared. Or in this case, as we set it up as a function, f of x equals x squared. First thing I'm going to do is go ahead and plot y equals x squared. So I'm going to make a table of x values and y values. If you're a little confused, you can imagine it as y equals x squared. So if I have my input of -3 for x, my output is going to be 9 because -3 squared. Remember, when you square these, you're thinking about it in parentheses outside those values. So that gets me 9. -2 results in +4, -1 is 1, and then the rest continues. So what I see is that I can take those points and graph it on some graph paper, and then I'll see that my graph creates this nice little shape. This shape right here is called a parabola. So when you hear the word parabola, you're thinking about this shape, and it's referencing the graph of a quadratic function. Now the parabola has certain properties. So in this case, we're going to take a look at a quadratic graph that's also known as a smiley. It'll make sense in a couple minutes. So first thing we need to see is that this parabola has two x-intercepts. A parabola can have 1, 2, or 0 x-intercepts. That is where the graph crosses the x-axis. Then we also have the y-intercept. That is where the parabola crosses the y-intercept. Now it only crosses through in one point, and that's going to make sense. Actually, that should make sense now, because if it crossed in 2 points, then your graph would not be a function. Now there's also a line of symmetry. That's the spot that cuts the parabola exactly in half, and that's a terrible line. However, through the magic of technology, there we go. I have created a line of symmetry right there. And when you're defining your line of symmetry, you're usually defining that as x equals something. Your x-intercepts and your y-intercepts are set as ordered pairs. So the important words here are line of symmetry, x-intercepts, y-intercepts. Now, the last point that we're going to be talking about is this point right here. That is known as a minimum point. And that is also referenced as an ordered pair. So remember your x comma y, etc., etc., and so on and so forth. Except your line of symmetry, which is an x equals. So let's take a look at -x squared. Well, what happens with -x squared? If I have y equals -x squared, again, order of operations here, I would square this, which would get me a +9, but because I have then negative in front of that x squared, my answer is -9. -2 yields me -4, -1 yields me -1, +1 also yields me a -1, +2 yields me a -4, +3 yields me a -9, so my graph then ends up looking something like this. Now, it's still called a parabola, but in this case, it just looks a little different. Its orientation is different, and there are a couple terms that are going to be slightly different. So in this case, I have a frowny parabola. So if you look back, here was my smiley parabola, right? Smiley, yes. Okay, and then this gives me my frowny parabola. All right, but let's more importantly talk about the certain properties. I still have x-intercepts right here and here because the parabola still cuts through the x-axis, and in this case it cuts through in 2 points. Sorry, this is just one x-intercept. There we go. I still also have a y-intercept. That's where my graph cuts through the y-axis. But instead of a minimum point, and I still have a line of symmetry that cuts my parabola directly in half. So my line of symmetry, and that's still an x equals coordinate. Again, these are ordered pairs. Ordered pair, ordered pair. But instead of now a minimum point, I have a maximum point. So now I have an ordered pair that represents the highest point of my parabola. So here's what I want you to do. You're going to draw the graph of y equals x squared minus 4x plus 4. I want you to label the minimum point, or it could be a maximum, you never know. Actually, you do know, and there's a way that you can tell. But anyway, label the minimum or the maximum, the line of symmetry, and the x-intercepts. And you know what? Because I feel like it as well, label the y-intercept as well. Because I am so mean and cruel. Ha ha. Ha ha ha. Ha 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 ha. Okay. See you later.